This is going to be one of those times I'm going to warn everybody. This is definitely partly a discussion. So part of this particular talk is I really want a lot of input from all of you here as to how you actually use Airflow from a DAG authoring standpoint, because this is very much a talk about wanting to get your input into how to make the DAG authoring process easier. And specifically for how we have actually been using and defining common Airflow integration abstractions. So I'm Vikram Koka, the Chief Strategy Officer at Astronomer, also on the Airflow PMC, and been working on this for about since 2019. So this is a slide which we used as part of the keynote a couple of days ago. And the general notion is everyone uses Airflow to integrate across a variety of different data warehouses, blob storage, AI providers, compute engines, Spark, so on and so forth. And I think this is completely absolutely known, and all of you actually tend to write DAGs to kind of operate on this from a pretty high level. Now, if you kind of go into one level lower on this, or one level deeper, all of the integrations into the data stores, whether it is Snowflake, or you might be kind of going into Postgres, or you might actually say Redshift or BigQuery, or you're actually accessing files from a blob store or local file system. All of the interactions into data are through what we call providers. Right? And these, whether you're using the providers natively or you're actually using just like a Python operator and doing everything completely on your own, is something which we would like to know as a project, because we have about 1,600 odd hooks, operator sensors. We integrate into about 230 data ecosystem elements, right? Data systems. And all these providers are actually quite valuable, we think. But I think the key question is, do you actually use them, right? And we have tried to generalize this further towards making it easier to use through what we've called common providers or common provider abstractions, right? So we've actually developed this for Common SQL to be a common abstraction over all database integrations, whether it is Postgres, which you're using locally, whether it's SQLite, whether you're actually using Redshift or BigQuery or Azure Synapse, and or like any other kind of database whatsoever. Right? The same thing for I/O. We've also recently done this for all the event-driven scheduling, about being a common pattern towards any event-driven messaging system, whether you're actually listening or you want to publish, and so on and so forth. Right? So we've actually seen this across a few things. Common.SQL was introduced in about 2023. We've seen a fair amount of integration or a fair amount of adoption for Common.SQL. We've seen a lot of people use this. I think it's right now supports about 17 roughly different sets of databases. You can access them completely seamlessly. It also supports different dialects. Again, it goes all the way from SQLite, Postgres towards SAP HANA. So it's a very huge range of database integrations that it supports. It's also used as a base for other packages such as DBT. I think Cosmos uses it. The key interfaces include the database API hook. Typically, most people use the execute SQL on top of it. It can also support loading data into the database, getting data from the database, and data quality checks are also built on it. Just out of curiosity, anybody in the room uses it or not? Okay, 3 people. Awesome. Oh, 4. So it's about, in this audience, is like a fair percentage at this stage. So one of the key things so this is part of the elements, right, is which operators do you use on it? Do you just use the execute SQL? Do you use anything more than execute SQL? Just execute SQL as just being the way to kind of execute SQL. You use the checking as well? Awesome. So partly the whole notion, and this is what we want to actually find out, is what is useful and what is resonating versus not, right? Because we started using this. The second operator, which is about a year or so ago, we introduced was common.io. And common.io was, again, meant to be similar, like an abstraction on top of any kind of blob storage, whether it is local file system or S3 or GCS blob storage or so on and so forth. I personally think that the most common use case, which most people are actually using this, is as a custom XCOM backend. So you can pass data, or pass a large amount of data between tasks. Anyone using common.io? And if so, for what? Nope. All right, interesting. Okay. So useful to know that as well. Again, a negative is also really useful. And I'm not saying that we're going to immediately drop support or anything like that, but it is useful to kind of understand what people are actually using and why, and so on and so forth. Common messaging is something which we used, which we introduced as part of Airflow 3. So this is very, very new. This is the foundation for all the event-driven scheduling integration. This is initially was supported for SQS. We had a jump with respect to adoption for Redis, Kafka. I think the Azure one is in the works. I think Google PubSub, there was a PR created and then removed because I think that was accidental, but I think somebody else was looking for doing this, publishing this as well. I'd suspect this is too early for anybody to use, presumably because nobody has started really, probably kind of really starting to use event-driven with 3.0 yet. Anybody using this yet, off chance? So this is, but I actually expect that we're going to see a fair amount of adoption on this one as well. The key thing is hey, you register a schema, and then you can say at different stages, I'm using Google PubSub if you're running on Google Cloud, versus like in Amazon, you'd actually be using XQS or Kinesis, depending on which provider, versus Kafka and things like that. Again, that would be the abstraction we would expect. Too many early days. But I think the big point as to why we are actually kind of keen on this is we believe that having a single pattern to learn and then being able to incorporate in your DAGs and then be able to say just at a runtime or at configuration time, whenever it is, switch to a different connection on a different database, on a different cloud, would make it a lot easier to write DAGs consistently and be able to run it on multiple different clouds or local versus on the cloud and so on and so forth. That's kind of a real intent with this, and also so that people can learn to use these as part of DAGs, because right now, I can't imagine somebody using Airflow and not interacting with the database, nor with the blob store, nor with an event system, and that just can't exist. But because we've introduced these relatively recently, this is going to be a shift, but it is kind of looking as to how many people either are looking to start using this or have already built their own abstraction layers, right? And that is kind of the context which we're looking at. Is this a pattern which makes sense to you? For us, from a project management committee standpoint, we obviously believe that this is helpful, because then we can actually add a lot more providers and a lot more integrations which map to these consistent patterns, which makes it easier to test, which makes it easier to be consistent and release, so that all of a sudden you say, hey, look, you change the interface between this version and this other version, and therefore what gives, whereas there is a consistent pattern in actually being able to leverage these particular providers, whether you're accessing databases or blob stores or message systems or anything like that. So that's kind of the motivation behind these common abstractions, and what we're kind of maybe scary, but what we would love to move towards as being a proposal is to primarily say that these common abstractions are the most recommended way towards actually leveraging all these particular providers. But just wanted to get a sense even from people about what is the level of awareness about these commons. So clearly some people said common.sql. There's quite a bit of awareness. Common.io, probably the need hasn't come up yet, and messaging is pretty early, so that would be very, very recent. But ideally, all the asset watchers, when you go forward, would be purely based on a common.message abstraction. There'd be not any other way to kind of do that because there's no reason, but especially because we kind of introduced this very early on. And that's the consistent way we'd actually like these to kind of go forward for consistency. Now, key question, this is why I said, there's an absolute discussion-oriented element of this. Does this make sense, or are we completely, absolutely barking mad?
I think it makes sense. I'm going through a thing where if anyone, everyone starts with like a single cloud, and then as your enterprise grows, going to multi-cloud, I think starts to become a thing. And as we're using both GCP and AWS together, like all of our Airflow stuff is on GCP, but it's hard to make that transition without a common interface.
Right. Anybody else? Any other feedback on this? Because there's a couple of follow-up things, it's right, because you want to say what would make it easier as well.
Yeah, thanks. So I work on a really small data engineering team with just 3 people. We're, basically operating in a VM, and we started just using Python operators basically to do most of what we wanted to do because that seemed straightforward to us. And over time, I've tried to use the operator more. So I mentioned the common SQL operator. I think we actually started with the Postgres one, and then kind of were forced into adopting common after upgrading.
Forced into what?
Well, I think it was a deprecation warning, so not forced, but trying to get ahead of it. So I think it seems really useful. I mean, I guess for me, maybe it's more of a learning curve, or just like how to use this pattern effectively for your use case. And so I don't know if that's a documentation challenge or examples challenge, but I think that that's something that trying to reinvent the wheel to some of the other discussions that have gone on here this week is something we'd like to avoid, right? Just because of the maintenance burden. So I like the idea of common interface, especially as our enterprise looks to migrate to a different cloud as well. So I think it's a good idea. I think the barrier that I see is really just about kind of learning how to fit it into your use case. Thanks.
Awesome. Thank you. And actually, while you have the mic as well, please feel free to share about, are there things missing in these operators or other abstractions? Because this is really what we're trying to get at, is to, obviously, we've thought about common.database, clearly, common.io, messaging, but are there other abstractions that you feel like are absolutely missing, or other operations on these abstractions, which is hey, I can't believe that you missed this?
Yeah, I can go next.
Please.
Yeah, definitely these are very helpful, but I can see in the future right now, like I work for Amazon Web Services and supporting maybe 50 plus applied scientists, and the data or the amount of data we are generating is like petabytes within an hour. And it's not scalable using SQL. So the interesting use case I usually do is basically get the raw operators and inherit it, create on my operators. Like I definitely add more functionality on execute. Rather than using SQL or like any other compute services, I will ask my scientists to like bring your own juice kind of thing, either Fargate, EMR, or any other thing. So I would like to see something related, not with SQL using as a computation, but more generic, just like there are certain things that are being developed, just like for AI, capacity blocks are coming in, and we have like so many hard Fargate nodes are there. It's just not just EC2, but there are so much things that has been developed from infrastructure point of view. So currently in Airflow, it's just you call an EMR, there is an EMR operator, but there is no functionality. It's just like think like a t-shirt size, right? My database can be like one scientist can just execute terabytes of data, but other required petabytes of data. So we'll definitely want to have some t-shirt side associated, which is at backend, we can call like Fargate, we can call capacity blocks, or like a unified, just like SQL you created or messaging. It should be like unified for just for support of scientists for AI building and LLMs. We definitely need like a lot of data exists, and mostly the data exists in my environment. It's S3, it's not Redshift, because it's difficult to get that petabytes of data within some time. So if they have more juice, they can easily query the data faster. So I would like to see in future if we have something related to computation rather than SQL is good to have. But down the line, as we see the future as like a big data engineer from past 10 years, I see the requirement will be like, bring your own juice. I can help you with the infrastructure and setup, but you have a separate juice for yourself.
Got it. Thank you. I'm sure I'm going to have follow-ups as I process. And I could see Jarek kind of thinking as well during that particular comment as well. So I'm sure we'll actually have follow-ups. But thank you.
All right, probably throw out my comment because I'm not a user of Airflow. But what I was wondering about is the relationship between BPMN flows and using those to trigger with very low latency. And that problem set for like highly scalable financial services. So that's the problem area. And I'm not an Airflow user, so I'm really very novice question, I suppose.
So, no, actually, I think that's part of the problem set which we are targeting with event-driven scheduling, is to be able to drive Airflow workflows as a result of events coming in. Now, there are definitely boundary conditions which we kind of get into about, like, what is real time and what is volume and what is latency and stuff like that. But slightly different element there.
Okay. Anyone would like to share
Anyone else?
their thoughts?
Oh,
Yeah, just kind of echoing what the Amazon guy said about having a common compute. I think because there are so many different ways to run Docker containers, Kubernetes, obviously the local Docker, or AWS batch or GCP batch, GCP Vertex, there are Fargate, ECS, like these are all running Docker containers. They should be pretty similar for a common compute.
got it. Okay. That's good feedback. So here are some things which we had actually talked about with respect to common.SQL. Caxel had brought this up yesterday as part of the MCP conversations as well. So I think you had mentioned that you're also using it for data quality checks. And one of the things we've actually talked about is integrating common.SQL with an LLM for schema drift and data quality checks, and to kind of perform other operations on top of it. I mean, there's lots of imagination kind of stuff which kind of goes in, which is like, hey, can you infer checks? Do you actually have to specify? Has anything changed? And do we actually just kind of leverage it as well, right? So that's one thing which has kind of been brought up. Any resonance with that? I mean, it's like, again, schema drift is a problem which we've actually heard consistently with a lot of people who deal with structured data. That's a potential for, like, actually moving forward. Common.io, I was actually surprised that absolutely no one is using Common.io, but there's a few areas wherein we've actually seen relatively common, that's a pun, not deliberately intended, but it is very relevant with respect to two sets of use cases. One with respect to dynamic task mapping, because there's so many times wherein people write workflows which are based on a bunch of files showing up on, for example, S3, and wanting to trigger a workflow based on all these things showing up. And then saying, hey, I want to process these in parallel, which typically is a common dynamic task mapping use case. And also directly interacting with triggering events and triggering basically workflows based on it. And in fact, I think that was Vincent's first example when he started working on event-driven scheduling, with exactly that. Are people solving this in a different way today? I assume that this is a common use case, but how is this being handled today? Because this hasn't been really brought up a whole lot, I think, in this particular conference yet, about the interaction between files and event-driven scheduling, unless, I don't know, Vincent, if anyone brought this up to you, but a little bit surprised that this hasn't come up. So kind of curious from this audience. Just become a solved problem already?
Yeah, before Airflow came out with event-driven scheduling, it didn't seem like the latency between different Airflow nodes was good enough. We're most latency between Airflow nodes is like seconds, like 10, sometimes 30 seconds. And so we decided to go with GCP workflows or AWS step functions to get that file-based concurrency and lower latency. So I'm interested to see how Airflow eventually evolves for lower latency.
Got it. Thank you. Anyone else?
Hi. So I know that's a big problem for sure. So how I am handling is basically you are getting the files in real time. So I'm using a combination of Airflow and Iceberg, Apache Iceberg. So Iceberg has a tendency, like you get the files, basically let's say it's raw files in JSON or CSV. So I have some script written, which in real time, maybe Kinesis Stream or any streaming system converts that file, read the schema and store it in a binary format in protobuf or Parquet using Airflow, but I'm storing in Apache Iceberg. The good thing about Iceberg is it maintains the metadata and a snapshot. So at the certain point of time, I have like a state which may not be like 100% real time, but it's not much difference. You can definitely maintain hashing and everything. It depends on your use case. But a combination of like streaming using Apache Airflow and Apache Iceberg, I'm able to achieve this situation as a state which is consistent at a particular point of time because it's automatically storing the snapshot in Apache Iceberg, and you can query anywhere using any orchestration tool again.
Interesting. And are you, by any chance, using anything else like to query the data from there as well, or you're from Iceberg directly, or you're just kind of doing that through Redshift or something?
So yes, we are querying it, but again, being Redshift is a great data warehouse, but personally I don't like much because it takes away the flexibility from an engineer. So I prefer I provide different Airflow environment which can spin EMR or Fargate or GCP compute, because being scientist, you can't differentiate because they have different models or different running, and it's very difficult to compensate how they will speculate. So it's better to give them their flexibility and define the compute. But in Redshift, it doesn't, you can't differentiate. You can create groups and everything, but it doesn't adds value. Like supposedly I am one of the scientists and right now I'm writing a lighter model and later on I'm writing a large language model. So it basically cuts it out. So yes, I'm using it, but using PySpark and Trino. Yeah.
Got it. Thank you. I'm actually quite surprised about the filerl not actually being brought up as being a problem. So that's why it's kind of interesting. I wonder what we're missing on this one. Or it may be that people have just kind of solved it as you did with other solutions because Airflow hadn't had the low latency for so long.